Hi guys. So in this video, we're going to keep going with more of our conics, and we're going to take a look at the parabola. Okay, so this is a shape that you are all familiar with, right? You've studied parabolas before, but we're going to look at it a little bit more differently in this class than you probably have in the past. So if you look up here, you can see sort of the geometric definition of a parabola. I'm just going to kind of go through and point out some of the key information for you and some of the points that we're going to need to use while we're sketching these. Okay. All right, so if we have our parabola here, okay, then we know that right through the center of the parabola, we're going to have the axis of symmetry. So that's something that you should have seen in the past. So this right here, my dotted line, is the axis of symmetry. Okay, and of course another point that you have all seen before is right here. The minimum point of this parabola is the vertex. Okay. Okay, now a few things that are new. Okay, so this point that I have right here in blue, this point that sits inside the curve of the parabola on the axis of symmetry is what we call the focus. Okay, and then this line down here that I have perpendicular to the axis of symmetry, this is called the directrix line. Okay, now these are relevant to the geometric definition of a parabola. So if you read through this, it says a parabola is a collection of points in the plane that are the same distance from a fixed point F, so that's our focus, as they are from a fixed line D, so that's our directrix line. Okay, so basically it's saying that if we have some point over here on the parabola, then the distance from that point down to the directrix line is always the same as the distance from the point to the focus. So those are always equal distances, okay? Now, you don't really need to know this for the sake of solving problems, but just want you to know that this is how we're defining a parabola geometrically, okay? So the distance between any point on the parabola and the directrix line is equal to the distance from the point to the focus. So that's why we're using these two pieces here, is because this is how we're defining our parabola. Okay, now in terms of application problems, we'll be looking at things that are shaped like a parabola, in which case something like, say you have a parabolic mirror or a parabolic lens, then light would be focused right here at the focus. So that would be sort of where that would come in real life. Okay. Okay, but for our purposes, really all we need to know is that the distance from the vertex to the focus is the same as the distance from the vertex to the directrix line. So either way about it, this distance here is equal. I'm going to call it P. Okay, because the vertex is, of course, a point on the parabola, and for every point on the parabola, the distance to the focus is equal to the distance to the directrix line. All right, now one other thing that is new for these parabolas this time around is this line right here. That line is not straight. Let's try and make that a little straighter. Okay, so the line that goes across the parabola at the focus. Okay, so the line that goes across the parabola at the focus, so perpendicular to the axis of symmetry. This is called the latus rectum. Okay, so again, that is the distance across the parabola at the focus. Okay. All right. So now let's go ahead and take a look at the equations of parabolas. So these are again going to look a little bit different than they probably have in the past. So not only are we looking at parabolas that open up and down, but we're also going to be looking at parabolas that open left and right. Okay. All right. So for these first two, okay, notice that we have our y squared and the x is not squared. Same thing here, y squared, x is not squared, okay? And these two, these are gonna be our parabolas that open left and right, okay? Down here, we have the x that's squared, y is not. X is squared, y is not. These are our parabolas that open up and down, okay? So the way that we can tell the difference between right and left and up and down is from this piece right here. So the 4p versus a negative 4p, okay? So y squared tells you it's either left or right. If it's a positive 4p right here, it's going right. If it's a negative 4p, it's going left, okay? And here, x squared tells you it's either up or down. Positive 4p is up, negative 4p is down, okay? All right, now what that p-value tells you is the distance, that was this guy right here, that p-value tells you the distance from the vertex to the focus, or equivalently the distance from the vertex down to the directrix line. So p is the distance from the vertex to the focus, or the vertex to the directrix line. Okay, the whole 4p is going to tell you the length of the latus rectum. Okay. All right, the other important thing here is that the h and k in this equation is always going to tell you where our vertex is. Okay. So let me give you a quick sketch of some of these. Okay, so let's start with the first one. So we have a y squared positive 4p, so it's opening to the right. So somewhere on here, we're going to have a parabola opening to the right, okay, which means that the focus is going to sit to the right of the vertex, our vertex being right here, and the directrix line is going to be the same distance to the left of that vertex. And of course, the axis of symmetry would go right down the middle, and the latus rectum would be the distance across the parabola at the focus. Okay. All right, this next one, a y squared with a negative 4p is going to open left. So somewhere here opening to the left. The focus will be to the left of the vertex, and the directrix line will be to the right of the vertex, and perpendicular to the axis of symmetry that goes right down the middle. All right, if we have an x squared and a positive 4p, this is going to open up, opening up. Vertex will be our minimum. The focus will sit above the vertex, and the directrix line will be below the vertex, perpendicular to the axis of symmetry that goes right down the middle. Again, latus rectum would be the distance across the parabola at the focus. And then lastly, an x squared with a negative 4p is going to open down. So the vertex would be our maximum. The focus is going to sit below the vertex, and the directrix line is going to be above the vertex, perpendicular to our axis of symmetry that goes right down the middle. Okay. All right, guys, so these are our equations for parabolas that we're going to be looking at here. So in the next couple of videos, we're going to actually take a look at some examples, find all these features, and then graph our equations.